To write equation of plane, we need two things. Number one, we need a point, and number two, we need a vector normal to the plane. If we're given these two things, we can find the equation of plane. Now the case we are given here, 3 points were given. Here is a plane given to me, and we given here 3 points: point P, point Q, and point R. And we are asked that we want to find the equation of plane passing through these 3 points. But what do we need? We need here two things. We need a point. Points are given, but it is missing. Normal vector is given. How you can find the normal vector? If you remember, we have two vectors A and B, and we know that if we take the cross product of vector A and B, what we get here? We vector A cross B. A cross B is normal to A, and A cross B is normal to B. That's the definition of our cross product. And we take the cross product of vector A and B, and we get the vector A, and the component of vector A are A1, A2, A3, and we have vector B. The component of vector B are B1, B2, and B3. And we want to find the cross product. I say it's my normal vector. I say A cross B. And what's the definition of this one? We are having here I, J, and K. We get here A1, A2, A3. We can have here B1, B2, and B3. So it means we can find here the cross product. What this give me a message? Message is that if we find two vectors in a plane and if they take the cross product, we get a normal to the plane. For example, these are the three points. We can write any two vectors. We can get the vector PQ and PR. So we have vector PQ. I have the vector PR in the plane. Now I want to find the normal. What's my normal? My normal is PQ cross PR. That gives me the normal vector. So this is my case 1. Case 2 is that we have a plane, and in this plane we are given here a line L, and we get the point P. I want to write the equation of the plane in this case. Now when I want to write the equation of the plane in this case, I need two vectors, but I'm given here a one point on a line. So parallel to the line, I can find a vector A. Vector A is parallel to the line. I get here point Q and join this point Q with point P. So get two vectors. I have vector QP and I have vector A. So when you have these two vectors, I can find the normal vector. So my normal vector will be equal to, my normal vector is QP cross A. That gives me the normal vector. I take one more case, case 3. My case 3 is that we are given here a plane. We want to find the equation of the plane. And in this plane, what's given to me are two lines. I've given here line L1 and line L2. Is given here is line L1. This is my line given to this one, and I give another line. I say this is my second line, and this line my L2, and I'm interested to find the equation of the plane. So obviously, when you have two lines, I can get two vectors. Parallel to line L1, I say this is my vector A, and parallel to line L2, this is my vector B. What's my N? My N is A cross B. So in any case, when you're having here any plane, we want to find the equation of plane, we need two vectors in that one, in the plane. And we take the cross product, we get normal to the plane, we take any one of the points, we can write equation of the plane. So that's we need here, again, the definition of the vector product, that we must not forget that we take here the determinant I, J, K, and A1, A2, A3, B1, B2, B3, and that give me the solution of the problem. So I give you an example for this. We take the example. We want to find an equation of the plane determined by the points P, 4, 3, 4, minus 3, 1, Q, 6, minus 4, 7, R, 1, 1, 2. So as I explained you before, that we need two vectors in a plane. So these two vectors are vector QP, PQ, and PR. For PQ, when 6 minus 4 is 2, minus 4 plus 3 is minus 1, 7 minus 1 is 6. And then PR is 1 minus 4 is minus 3, 2 minus 3 is 5, and 2 minus 1 is 1. So this is my vector PQPR. Now I want to find the vector normal to this one. So the vector normal to this one is my vector N. Or you can find, I take the cross product of these two vectors. I take the cross product vector PQ and PR. So, so we get vector N. So it can be like this one, or we can have here like this one. Taking PQ, PR, we can say this one is like that. That is the rule we are having. So QP, QPR, we get here IJK, and QP is 2, -1 and 6, and PR is -3, 5 and 1, and solve it. We are opening the determinant I into cofactor is -1, 6, 5, 1. Cofactor J, cancel this row, this column is 2, 6, -3, 1. Cofactor of K is 2, -1, 3, 5. So get -1, -30, -31. 2 minus plus 18, 20 with minus sign is minus. We have to get a plus sign. Here coefficient of this one is plus, this one is minus, and this one is plus. Then we having here this 2, 10 plus minus, this minus, minus is plus, and then minus. 10 minus 3 is 7. So it's my n. So I get here vector n. So here we can find any of the point. We can take point P, we can take point Q, we can take point R. There are thousands of the points in a plane. Here we have 3 points. We say let we take point P. We take a point P because we're having here 3 points. We can take any one of the points. That's why I say we let point P is equal to 4 minus 3 and 1. And there we can write here the value of x1. We have the standard equation a1x minus x1, a2 y minus y1, a3 z minus z1. So what's my a1? a1 is minus 31, x minus 4, then a2 is 20, and y1 is minus 3, minus become plus. And then we're having here a3 is 7, and our z1 is 1. So it's this. And we simplify this one, we get here minus 31x minus 20y plus 7z. And we are having here, when we calculate, plus 57 is equal to 0. So this is my equation of the plane. We have another example. We were given want to find equation of plane that contains the point P and the line. This is point P is given and this line is given. So we want to find the equation of plane. What we need? We need two things. We need here the point. The point is given to us. And we need the normal vector. To find normal vector, we need here two vectors in the plane. So one vector is parallel to the line. We take here this vector coefficient of A. T is A1, A2, A3. This 1, 2, and minus 1. Second vector to find, we can get a point on a plane line. We can have infinite number of points on the line. For each value of t, we have a point on the line. We take t equal to 0. The point will be 5, minus 1, and 7. So we have the point. So we can find here now this point is on the line. This here is 5, minus 1, and 7. So I can write point P, QP. QP, this is 4, minus 5 is minus 1. And then here is minus 3, minus 1 because minus 2. And get here 0 minus is minus 7. So this is my vector PQ. So I get here two vectors. And when you have two vectors, I can find here the dot product. And with the help of their dot product, I can find my normal. So it's the cross product. This here is QP cross vector A. Sorry, I write here A into QP, vector A cross QP. So what's this? I get here, this is my vector A, and this way. So I have vectors A and QP. My vector A is 1, 2, and minus 1. So I write here 1, 2, and minus 1. And vector QP is minus 1, minus 2, and minus 7. So I can multiply them as dot cross product. The coefficient of I is minus 14, and then we having here minus 2 is minus 16. With the minus sign, and we're having a minus 7, and we are having here minus 1, minus become plus, because this here is plus sign, this minus sign, and this minus make it plus. And then we're having a minus 2 and plus 2 that become 0. This is my n. So I have my n, and I can take my point is given to me, point P. So we can write the equation of the plane. Equation of plane that is contains point P, because it's given us the point P, and the point P is given to me is 4, minus 3, and 0. And we have to find the normal vector, and my normal vector n is having the coefficient minus 16 and 8 and 0. We substitute here is minus 16, x minus x0, x minus 4, x1 plus 8 into y minus y is 1, that's equal to y plus 3. And then z is 0 into z minus 0 is equal to 0. So again, this is equal to 0, so we don't bother about that one. We solve this one, we get here minus 16x, and then we have plus 8y, we have plus 64, plus 24 equal to 0. That gives me a 16x minus sign plus 8y, plus we're having here 88. and that's equal to 0. This is my equation of the plane that is containing point P and passing through the line and contains line L. And with the help of this one, we solve our problem. And you can see it here that what was the idea? Idea was this one that we were given here, the point and the line, and there we need two vectors to find. So we having the point P and we take a point on the line, point PQ is one vector, and the other vector is vector A parallel to the line. Then we can just take we have vector A and vector QP. We just take the cross product. Then I get here the vector normal to the plane. I get here normal vector, and I have point P. I can write equation of the plane.